Hi there, welcome back. Welcome back to the BeoCenter 5000. This is the third video in the series, and yeah, it's been a while. But I think you'll understand when I tell you or show you why. If any of you have sort of gathered an idea of what my workspace looks like, this is the new version. I decided to rebuild the workspace completely. And of course it started off with, let me put up a couple of shelves, and that sort of developed and developed and developed, and before I knew it, the whole thing got done, the walls got painted. It's just one of those things, starts off small and it becomes a massive, massive task. And the amount of sawdust and powder and dust and everything else that I've taken out of this room is unbelievable. But I'm happy to say I've now got a bigger workspace, a much bigger workspace. I've got the shelves that I want. I can get all my tools where I can get easy access to them. And I'm sure this is going to make life a lot easier for me. I've been planning to do this for quite some time, but you know what it's like. Just the idea of removing everything. All the equipment, all the components, everything had to be removed, put aside. The wood is the easiest part. But yeah, I think I'm ready now. I've got all my plugs there. Probably not enough. I'm sure I'm going to have to put in some more. Absolutely sure of that. But at least it's now a work in progress that's usable. Anyway, before we get back to the BeoCenter 5000, I just wanted to explain why this thing has taken so long, and with the exception of possible adjustments I need to make to the workspace, maybe I won't waste so much time on it in the near future, and we can get this thing going. All right, let's carry on. Okay, so I guess since this is still coronavirus lockdown and I still haven't received 2 radios that I've ordered, and so I'm bored, I'm going to go further into this rabbit hole, which is the Bang&Olufsen BeoCenter 5000. And as I said at the start, I'm not sure that this will come to an end because we may get to a part where it cannot go any further, namely microprocessor stuff. But anyway, this part has all been done. So we know that we have our amplifier working, our power amp working, both channels. We know therefore that the supply to the power amp is fine. However, we don't know anything before that. So what I've done is I've fed the input of the power amp with the audio signal, which you saw in the last clip, and we have a decent wave coming out. Now we've got to see where this thing comes from, and the logic here is keep following, instead of following the money, follow the signal. So we simulated this input signal here, and we simulated this input signal here. Now we've got to see where they come from and tackle that next. And if we look here, we've got RR. That's right, RR. We've also got LL. Now, the labeling on this means that since there's no diagram number, the way these things work is they send a signal, they give it a name like this one, ZD3. That means on drawing 3 or diagram 3, you look for the Z signal. But this is RR and LL, which tells us it's on the same drawing. So if we follow this down here, we get to there. We could go left or right, but I know we're supposed to go right along here, and there's our LL and RR coming out of this section. So now we've got to see what the section is and if we can simulate the signal at that point. Well, this section is actually on something called board 5, and board 5 is sort of a switching and tone board, input switching and tone control board. Now, I know for a fact that it receives voltage supply from that supply section. So if we can test this section we need to make sure that the supplies are getting to it, and we need to make sure that the signals that go in can come out. So this part is simple. Assuming the power supply is fine to supply these ICs, we could feed a signal in here and in there. In other words, we could simulate what this is doing, and what this section does here is simply the loudness control. There's a switch, there's a switch. Now that loudness control is directly on board 5. So if we go back a bit more, we get to this chip over here. This is another TDA, what is that? That's a TDA 1074, half of one. And this is a full TDA 1074, which tells us it has 4 of these. What are these? Amplifier stages? Op-amp stages? I can't remember what the symbol is. Anyway, not comparators. Doesn't matter. What we do know is they show us, contrary to this one over here, it doesn't have DC control. Oh, it does. It actually does have DC control. That point A and that point B must go to somewhere, which gives it a DC bias control. But let's take it one step at a time. This thing here, what does this do? Well, it receives the signals through that capacitor there and that capacitor there. So we could actually simulate feeding the signal in here and here. And it takes that signal, and this is the tone board. There's a whole lot of filtering over here, and it goes through this first stage to the second stage. You can see that if you follow the signal in here, that's the arrow following a signal. It goes into this guy, comes out of this guy over here, goes back in. There's obviously some feedback over there. Goes back in through here into that, the 2 inputs of that guy, and that guy then feeds where we could have tested, simulated earlier. So this guy has a job of doing tone control, and we know that because if we look at this section down here, these 2 signals, these 2 lines go out to a bass and treble control. Now this means that this thing is on a separate little board, number 22. So we're following the logic, and we get more and more of these boards checked. And this bass control is actually done not with the usual, but it's actually with a DC voltage, because there's a 15 volt input over here. It's a supply, and it goes to drawing 1H. So we could go look at drawing 1H and see what that does, but it looks like it just brings in 15 volts. So you've got 15 volts across that potentiometer. It feeds both tops of the potentiometer. And then you've got the wiper, which is taking a proportion of that voltage from 0 to 15 volts. And it's feeding it into here for the bass control, and it's feeding it into here for the treble control. As far as I'm concerned, we need to make sure that those connections are there, that the voltages are getting there. So that shouldn't be a problem. And that will take us back to this point over here. We're still talking basically analog circuitry at the moment. Nothing digital has come up yet. But then we go back one step further. We've got another half of a TDA 1074, that's IC2, the other half of which is over here, IC2. And what does this do? Well, that feeds that signal out there and there. But it's got a feedback network, and it's got the inputs over here. So if we input our signal to here and here, we could actually test the entire circuit. But what is this thing doing? Well, we've got to see where it goes. And here it is. It goes to 2 separate little connectors, boards, one being the volume control. Yep, that's the volume control, and the volume control is also a voltage controlled volume control, because the top of the volume control over here goes through there to there, and it goes to the top here, which is the positive voltage, positive supply for these chips. So that's a voltage regulation or voltage controlled volume control. We could test that as well. And it also has the balance. So we know that this part of the circuit, this part, this module, is volume control and balance control. So if we feed the signal in here and we get something out the amplifier, we'll be able to test the volume control, the balance control, and the treble and bass. Is that it? And the loudness, okay? So basically we're doing the tone circuit. Now where does this come from? Well, this comes from here. And here is this guy over there. And the other one is this guy over here. So if we look at this, well, let's look at the top one. We look at this guy over here. Basically, this is just a switch. So if you imagine that you've got a rotary switch and it's 4 pole, two pole, 1 pole, 2 pole, 4 throw, 1, 2, 3, 4. And these work in tandem. If you imagine this to be a mechanical switch that you just rotate, okay? If you have it in the top position, that's your right channel, that's your left channel. Top position, what does it do? Well, it comes back here. This thing here is just a buffer, and it receives your FM signal. If you put it in position 2, it receives your AM signal. Your AM signal, we know, is a mono signal. So there it is there. It doesn't go out there like these guys do. It comes down here, down here, down here, and there's the input to the other AM signal. So the same AM signal, which comes in as mono, makes sense, is split here into left and right, which are identical signals. You just want them to go through both sides of the amplifier. And that's where this happens. So you could actually feed the signals in where these guys are coming in. Now we know there's connector 14, pin 3, that's that guy. Connector 14, pin 5 is that guy. Pin 6, pin 8, there's the numbers there. Pin 1, pin 6, what is that? Pin 11 and pin 9. So we can check from these inputs, if we had a way of rotating the switch, we could check that these inputs are getting through, okay? Now, to get this switch to work, because this bloody thing is digital, you have to send it a binary code on here. So 000 will give you one position, 001 will give you another position. I don't really know what the table is. It's down below. It tells us what the functions are. But quite frankly, at the moment, what I want to do is I want to get it to the point where I can feed the signal at the output of the circuit, which is that guy there, and that guy there. And that means that I can confirm that all the analog part of this is working. All this section over here is working. There is one more thing over here, which is actually a remote volume control. I forgot this has also got a remote. But what this does is you've got signals coming in here, and I presume this comes from your remote switching, and it will give you different voltages because these resistors are setting the different voltage levels. It switches in a particular resistor depending on which of these has got a signal on it. Okay, but we don't worry about that at the moment. We will be trying to get this analog volume control to work. So that's also part of the circuit we have to look at later, because it depends on external circuits, external connections, okay? And these are drawing 3, V, drawing 1, J. So it actually depends on two sections, but I think drawing 1J, I think is just a power section, power supply. Yeah, I think that'll probably, drawing 1J or J drawing 1 will probably be a power section, power supply. And then these guys, V, drawing 3V, drawing 3W, X, Y, Z, this will be the actual volume control. So that we can look at later. However, what I've done is, oh, there's one more thing over here. It's the record level. If you look at where the signal comes out of the switcher, whatever you've selected comes out, goes up there and goes into the tone boards. It also comes back here into a pot. This is a normal analog volume pot, it seems, yeah? Yeah, it is. This is an analog signal, audio signal, 47K pot, and it's a dual pot, and the other channel comes in on this side, and this gives you a record level. So this will be going to record out there and there, and that's your ground. So you've probably got record out going to wherever your record out is at the back, but we won't worry about that. These guys are just grounds. So we've got quite a few that we can test, but first thing we need to do is look at that board. And this is the board in question. It is the tone board. It has the three TDA, this is a 1029, that's the switcher. And then it's got these guys used for volume and tone control and balance, 1074As, two of them. And we know that these are quads, 4 sections in each. We've seen that in the schematic. And what I did here is I looked at this and saw all the electrolytic caps that were in here, and I replaced them. It's got quite a few of those ROE brownies, which are really quite bad. These weren't too bad anyway, but they do turn bad, so I've replaced them all. And then I found, I looked at these guys, these axial 10 microfarad 63 volt electrolytics. They are in fact electrolytics. I didn't want to just necessarily change this without looking at them. I don't know anything about these caps. They're also, I believe they're ROEs as well, but I haven't heard anything about the longevity or not of these caps. So I decided to give this a try and leave them in. I tested them. They all test fine for value and for ESR. They're pretty low. I noticed somebody's already changed a pot over here, a trim pot. I'm not sure what that one is for. I'd have to look at the schematic a bit more carefully. But this board has got not much on it, but does have a lot of connections on it. You've got all the connectors to the volume pot, to the balance pot, to the, you know, those, which is this one? This is P13. The one I was looking at the left there with the audio inputs is actually P14, which is this guy over here. Is it? That's P15. That's P14 over here. So all the audio comes in here. I wanted to get this board ready to put it back in so that I can then start testing it. Still needs a bit of a wash, and that's what I'm going to do. And then we'll be able to test this entire board and see what comes of it. After that, if that works, in other words, if I can feed a signal in where this one comes out and that one comes out, and be able to make sure that everything else beyond this point works, then I can look at the truth table or the function table of this chip, and I can actually simulate this selection process with artificial digital signals. It's very easy. I think this is a 5 volt input. I'll have to check. So 5 volts is a 1 and 0 volt or close to 0 volts is a 0. So I can actually go and find a 5 volt source and a 0 volt source and then create that manually. And then I'll be able to do a test of this thing. But I want to take this one step at a time. These guys aren't on the same connector. So I've got to make sure that all the connectors that provide connectivity to these sections, the balance control, the volume control, and the treble and bass control, I've got to make sure that all those connectors are in there. And of course there will be extra signals like things like the input. So that's what I'm going to do next. I'm going to fit this board back in there. It's very easy. It literally works on clamps. This thing comes out the bottom underneath the front. It's the loudness control. It fits in, clicks underneath, and then there are 2 clips, 1 clip there, 1 clip there, and it stays in place. There are no screws, no hassle. This is actually a very easy one to do. But before I put it in, I'm going to photograph this carefully so that I know where the connectors are. Because once this thing is actually in the unit, it's very difficult to see the connector numbers. As you can see, there's P15 and there's pin 15. So you know that that's pin 1. Usually pin 1 is followed by a 0, an unused pin. But I don't think that's a rule. Actually, it is on here. it is on here. Pin 1 has always got a 0 afterwards, a no use pin afterwards, so you can determine which pins it is without looking at it. But I need to make sure I know where which connectors these are, so I can start connecting things as I need them and only as I need them. This is a very hobbyist way of doing this. I'm doing this for fun, more or less as an academic experiment. I don't know what the chances are that I'll finally get to the motherboard, which will be probably just before this stage, and get it to work. I don't really care. I'm just warning you in case you're the sort of person who hates getting halfway through a project and the guy says, hey guys, I've given up. This might happen. Not because I want to, but if I just can't get the motherboard to work, well, I really don't want to go into programming a chip. And while we're on the chip, it's not difficult. It's just a pain in the butt. Anyway, let me carry on.